Hello ladies and gentlemen, welcome to your video lesson on theoretical and experimental probability. You are going to be able to find and compare these different types of probability and understand the definition of each. So these are vocabulary words, theoretical probability and experimental. Question is, what's the difference? Well, if you've ever heard someone say theoretically, what they're saying is what should happen. Theoretically is what should happen, or what they think will happen, whereas experimental probability is what actually happens after you've conducted an experiment. So if you do something, you can have results of an experiment, and that's what you can say actually happened. So what should happen and what actually happens. What else we know about these is that they may or may not be the same, and they may or not be close. The greater number of times you do an experiment, then the closer that they should be. They should be closer in value. So if I were to flip a coin, flipping a coin, the results are heads or tails. So I would say that if the probability of getting heads should be 1/2. What it is in, if I did that 36 times, then that should happen 18 of the 36 times, theoretically. What experimentally is that the actual number of times that it happens out of 36. So the more often that you do an experiment, the greater number of times that you do it, these should be closer together. And we'll practice that. So we're going to look at experimental probability for what actually happens. What's the probability of something happening in an experiment? So if two number cubes are rolled 75 times, and the sum of 9 was rolled 10 times, we want to know what the experimental probability was of getting a 9. So we're looking for the probability of 9. What that means is that we're looking for the number of times 9 happened or occurred, and that's over the total number of rolls. So it's still looking at that probability equation, kind of. So what we know is that there were 10 with a sum of 9 out of the 75 rolls, which is the same as if we simplify, dividing those both by 5, we have 2 out of the 15 rolls had a sum of 9. So in the experiment here, what is the experimental probability that the sum is not 9? So remember that complementary event. So we take 100% of the rolls, or one whole, minus the number of times that did happen, will give us the number of times that it did not happen. So that means 13 rolls out of every 15 did not have a sum of 9. So for the next one, it says, what would the experimental probability be of rolling a sum that is not 6 if the sum of 6 was rolled 18 times? So again, this is the probability of 6, we know is 18 out of those 75 times. So we could simplify this right now and say, okay, this is the same as both 3 goes into both of those. So that's 6/25 is how often 6 was rolled. So how often it was not rolled is that complementary. We do 1 whole minus 6/25, which is the same as 25 over 25 minus 6/25 for 19/25. That is the probability that you will not get a sum of 6. So here we go, having experimental and theoretical probability. We'll talk about trials often. Trials is one experiment in a series of successive experiments. The graph here shows the result of an experiment in which a spinner with 3 equal sections was spun 60 times. We're going to find the experimental probability of spinning red for this experiment. So the probability of getting red is going to be the number of red occurrences compared to the total number, total only has one L, of spins. So the probability of red is, so red occurred 24 times I see in the chart, and I need to find the total number, which it told me in here is 60. If it didn't tell me, I could add all of these up, and that would give me 60. So then that would simplify. 12 goes into both of those. So the probability is 2 out of every 5 spins would be red. So compare the experimental problem found to the theoretical you found. Well, if they're equal, we didn't find the theoretical yet, but theoretically, if there are 3 equal parts, so we have the probability of getting red, if red is one section of the spinner out of 3 sections of the spinner that are equal, the theoretical is 1/3. So we're comparing 1/3 to 2/5. Well, this is, if we went percents, 33 3/10 repeating percent. And this is 40%, so those are fairly close. If we were to continue spinning more than 60 times, we would find that those would be getting closer together. So theoretically and experimental, not exact, but they're getting closer as we go up. So here's one really important part of theoretical and experimental is just predicting future events. We talked about this with March Madness, and now we're going to talk about it with like video streaming. So video streaming analyst examines last year's video genre selections of customers. Last year's selections are shown in the table. What is the probability that a person streamed a comedy genre? So first thing we have to do is add up all of these to find out the total. So because we're looking for the probability of comedy, and that's going to be the number of times comedy was chosen, which we see is 580. Out of the total, when we add those up, what we get is 2,000. So, out of 2,000. So what that means is the probability, if we simplify that, I believe 20 goes into each of those. So I get 29 hundredths. So now using that information to predict future events, suppose the analyst expects 5,000 customers this year, how many drama selections should be expected? So we're going to go back to our knowledge of proportions. So if we know that the probability, the experimental probability from previously of drama is that 450 of those 2,000 had selected that, then what we can do is use that number. So we can take that 450 out of 2,000 and say, if this is the case, then how many out of 5,000 would that be? So this is prior knowledge, setting up those proportions to find a missing value. So then we would do our cross products. And we would get that we have 2,250,000 is equal to 2,000x. We would divide then by 2,000 to find out that 1,125 is the value of x, which means that we could expect 1,125 people out of 5,000 to select drama. So using probabilities to make predictions. All right, boys and girls, rewatch what you need to. Find different ways that you would use theoretical and experimental probability in your daily life and come with questions.